Humans have always looked at the heavens and wondered about the nature of the objects seen in the night sky. With the development of rockets and the advances in electronics and other technologies in the 20th century, it became possible to send machines and animals, and then people above Earth's atmosphere into outer space. Well before technology made these achievements possible, however, space exploration had already captured the minds of many people, not only aircraft pilots and scientists, but also writers and artists. Here are 20 facts you didn't know about space. Space, the final frontier. Were you watching on February 19th as the very excited men and women of NASA managed to land the newest invention, Perseverance, on Mars from their command center 131 million miles away? Who could blame them for celebrating? Not only was the landing a nifty space feat, but the rover's mission is also sure to unearth untold numbers of amazing space facts as it wheels around the surface of the red planet looking for signs of past life, aided by the tiny but mighty 4-pound Mars helicopter. In its one-year mission, that'll work out to 2 Earth years, Perseverance will drill into the planet's surface to collect rocks, search for water, and figure out Mars weather. While we await new information from NASA, learn these other surprising things that scientists already know about the universe that you probably don't. Floating space water. Perseverance is currently looking for water and other cool stuff on Mars, but back in 2011, astronomers found an enormous water vapor cloud some 12 billion light-years from Earth. The cloud is the oldest, dating back to when the universe was 1.6 billion years old, and the largest source of water anywhere that we know of. How large? It holds 140 trillion times the amount of water that is contained in Earth's oceans, and almost impossible to conceive of vastness. Perhaps the coolest space fact of all is that this vapor cloud is feeding a black hole, and may also contain enough gases, like carbon monoxide, to help that black hole grow to 6 times its current size. Jupiter's shrinking red spot. Once upon a time, the telltale feature of Jupiter was 3 times wider than Earth, reports Space.com, and it's been shrinking slowly but surely for a few centuries. This amazing discovery may sound like an odd thing for a spot to do until you realize that the Great Red Spot, GRS, is actually a giant storm, a cyclone, in fact. And it's one of many high-pressure system storms that occur around the planet, due to all the gases that classify it as a gas giant. GRS has actually been raging for about 300 years. And although it is shrinking in width from its current incredible size of 8,000 miles, or 1 Earth, down from 3 Earths, it's not expected to blow itself out anytime soon. In fact, it's actually growing taller. TwoTone Moon. Saturn boasts 53 named moons, plus another 29 that are still waiting to be confirmed as actual moons before being officially named. Take that, Earth, with your paltry 1 moon. But Saturn's coolest moon of all just might be Iapetus. This 914-mile-wide hunk of rock is bright on one side and dark on the other, and its lighter hemisphere is as much as 20 times more reflective than its darker hemisphere. As it happens, the bright side is actually ice. The dark side, well, that's more complicated, and theories abound. One is that the darkness comes from particles released by a different moon named Phoebe. Another, more recent speculation has to do with heat, namely, the moon is rotating so slowly that the moon's dark material is absorbing heat and becoming ever darker. Our own moon is pretty fascinating too. Our solar system's hottest planet. The average temperature of Earth is 58.6 degrees Fahrenheit, that's 17.8 degrees Celsius. Meanwhile on Venus, our solar system's hottest planet measures in at 842 degrees Fahrenheit, or 450 degrees Celsius. It's not hot enough to melt steel, you'd need 2,500 degrees Fahrenheit to achieve that. But it is hot enough to melt lead, and significantly hotter than any life that we know of can sustain. Extremophiles on our planet can survive and thrive at temps of up to 206 degrees Fahrenheit at least. That's the hottest scientists have yet measured, according to BDC Earth. What makes Venus' heat so peculiar is the fact that it's not even the closest planet to the Sun, that's Mercury. But its super thick atmosphere traps greenhouse gases and turns it into a swelter fest. In case you were wondering, this is the distance from the Earth to the Sun. Faster than a speeding neutron star. Neutron stars come into being when massive stars explode and die. They are incredibly dense, so dense, according to Space.com, that a single teaspoon's worth of them would weigh 1 billion tons. How much would an entire one weigh? Well, each is 12.5 miles in diameter, so you can do some quick math to figure that out. Or maybe don't, because it will probably make your head hurt. These stars also have gravity that is 2 billion times stronger than what we experience on Earth. But perhaps the most amazing space fact about them is how fast they spin, 43,000 times per second, set into motion by the explosion that creates them. That speed, however, decreases over time. Diamond planet? That's what scientists were calling Super-Earth 55 Cancri for a while. A super-Earth is a planet that is much larger than ours, in this case, double the size. 55 Cancri East is south close to its star that it whips around it in a mere 18 days, 40 million light-years away from us in the Cancer constellation. Because of its proximity to its star, one of its most impressive features is its temperature, which measures a whopping 4,900 degrees Fahrenheit, 2,700 degrees Celsius. That heat, combined with 55 Cancri East density, caused scientists to theorize that the planet's core was made of carbon in the form of diamonds and graphite. This idea has been challenged, but it's still pretty exciting to contemplate. Ice volcanoes. We're used to thinking of volcanoes as spewing hot molten lava, since that's mostly the way they function on our home planet. But in space, a volcano can spew water, methane, or ammonia, and, as Quartz explains, those materials freeze as they erupt and turn into frozen vapor and volcanic snow. Called cryovolcanoes, these phenomena are pretty common. They exist on Pluto, Saturn's moon Titan, and Jupiter's moons Europa and Io, the latter of which is extremely active, with hundreds of vents, some of which NASA vehicles have captured erupting in real time, with plumes of frozen vapor extending some 250 miles. No one is quite sure what causes cryovolcanoes, although a strong gravitational pull might be part of the equation. Galaxies collide. Our Milky Way galaxy is 2.5 million light-years away from the nearest other galaxy, Andromeda. Nevertheless, astronomers say we're on a collision course that will someday destroy both galaxies as we know them. The two massive entities are speeding toward each other at a rapid clip, 250,000 miles, 402,000 kilometers, an hour, and when they hit, they will scramble up their stars, and some stars and planets won't survive the process. In the end, after about 1 billion years, the two galaxies will become a brand new, unrecognizable galaxy. Small comfort, according to National Geographic, impact isn't scheduled to occur for another 4 billion years. Cold welding. Here on Earth, when we want to fuse two pieces of metal together, we have to apply heat until the metals reach their melting points. In space, however, no heat or, really, any action at all is required to get two metal bits to stick together forever. The phenomenon is called cold welding, and it happens when the metal pieces slide over each other and wear away their protective oxide layers that, on Earth, prevent them from fusing. In space, though, that protection disappears, and the electrons from one piece of metal actually flow into the other piece of metal, making them one. Uranus a tilt. Being tilted on your side is nothing special for a planet. In fact, Earth is tilted at a 23-degree angle, which is what allows us to experience seasons. It's summer when our part of the world leans closer to the sun, and winter when we lean away from it. Uranus, however, has taken the planetary tilt to the extreme. It lies out there in space at a 98-degree angle. Not surprisingly, this has a massive effect on its seasons. Each one takes a whopping 21 years to play out, according to Earth's sky. Think about that the next time you complain that winter is lasting forever. The biggest valley of all. While Perseverance is learning more about our nearest neighbor, there's a cool space fact we already know about Mars. It contains the largest valley, a system of canyons, really, that we've found so far. According to Space.com, it's called the Valles Marineris, and it's 2,500 miles, 4,000 kilometers, long, which is 10 times longer than our beloved Grand Canyon. It was first spotted by Mariner 9 back in 1971. What caused it? Possibly a bank of volcanoes on the other side of the canyon ridge. Shrinking Mercury. There was a time when scientists believed that Earth was the only planet in the solar system to be tectonically active, that is, releasing heat by the movement of plates under the crust, which deforms a planet's surface and causes it to shrink. However, we now know that we are not the only incredibly shrinking planet. Mercury is shrinking too, a detail we only learned in 2016 when the Messenger spacecraft sent back data after orbiting that planet. As Space.com describes it, the data revealed cliff-like landforms known as fault scarps. Because the fault scarps are relatively small, scientists are sure that they weren't created that long ago, and that the planet is still contracting 4.5 billion years after the solar system was formed. Neptune's intense heat. Neptune is 2.8 billion miles away from the Sun, which means you'd expect it to be a frigidly cold and dark place. As NASA describes it, noon on this ice giant is like twilight on Earth, because the sun's rays are too far away to make it ever truly bright. However, Neptune appears to be making its own heat. In fact, it is making 2.6 times more heat than it receives from the faraway sun. Scientists hypothesize that this has to do with the pressure near its core, which builds and releases hydrogen. Nevertheless, while Neptune's center is a blistering 9,300 degrees Fahrenheit, its atmosphere is a chilling -361. Saturn's hexagonal storm. What shape do you think of when you think of storms? Here on Earth, we're accustomed to conical tornadoes and long ovals of hurricanes stretching across vast swaths of sky. But as you might expect, things are a little different out in space, and that goes for storms too. On gas giant Saturn, a storm has been positively raging for at least the last 40 years at its north pole. And it's a doozy of a weird shape, hexagonal, leading scientific observers to call it, or the hexagon. What's the reason for this unusual shape? According to new research, it could have to do with the planet's turbulent gas, or with zonal jets that extend many kilometers down into an area of high pressure. Space's vast distances. Here on Earth, we're used to measuring distances in minutes and hours and days, as in, it takes 10 minutes to walk to the supermarket, or 40 minutes to drive to the beach. The vastness of space means that we have to measure how long it takes to get around by years or, in many cases, light years. Of course, hopping in a rocket will be out of the question for anyone who's not an astronaut or a billionaire for the foreseeable future. So, thinking of walking to the moon? That would take you 9 years to span the 239,000 miles. How about a drive to the nearest star, Proxima Centauri? If you kept the pedal to the metal at a steady 70 miles per hour, you'd get there in 356 billion years. Twinkle, twinkle. Ever wonder why stars twinkle and planets don't? Then this space fact is for you. The truth is, if you were out in space yourself, you would not see stars twinkling. That phenomenon occurs only because of Earth's atmosphere. The pinpoint-sized light of a star hits our atmosphere only to be refracted by it, which sends it skittering off in a zigzag. That's the twinkle we perceive. Planets, however, appear much larger to us than pinpoints, so even though their light also zigs and zags when it hits our atmosphere, those motions cancel each other out, and we see only a steady glow. Wishy-washy Mercury. If you live in the northeastern United States, you might reasonably expect winter temperatures in the low 20s Fahrenheit and summer temps up in the 90s. In some places, extreme fluctuations are common. For example, in Montana, in one single 24-hour period, temperatures went from -54 degrees Fahrenheit to 45 degrees Fahrenheit. Still, that gap's got nothing on Mercury, where temperatures can vary over 1,000 degrees in a single day, starting out at -280 degrees Fahrenheit at night and ending up at 800 degrees Fahrenheit during the day. What kind of wardrobe you'd need to prepare for that extreme is anybody's guess. It's raining diamonds. There may be no such thing as a planet made of diamonds, although we're holding out for conclusive proof. However, there are planets where the atmosphere actually rains diamonds. On gas giants Saturn and Jupiter, lightning storms transform abundant methane into soot, also known as carbon. As the soot falls, it further transforms, first into graphite, then into bona fide diamonds about 1 centimeter in diameter. Before you start attempting to book passage on a diamond collecting expedition, be aware that these diamonds don't last. When they enter the planet's molten core, they melt, the BBC reports. Sand versus stars. A quote from Carl Sagan is cited often, about there being more stars in the universe than grains of sand on Earth. According to astronomer Bob Berman, this isn't the case. He calculated the stars in the known universe by doing some simple-ish math, multiplying 100 billion estimated stars per galaxy by an estimated 200 billion to 3 trillion galaxies. Then he counted grains of sand in a cubic centimeter and applied some more math. What he found was not proof of Sagan's citation, but something almost as amazing. The number of sand grains and stars equal each other.